That made me so angry.
2001 made a lot of future predictions, and some of them are right on the money.
Yeah, but I can't see. I can't read their lips.
There's all these conspiracies that came true, like MK Ultra and whatnot.
I think you need some type of dissipative force to get rid of angular. Okay, so what's the concern about survival here?
Let's calculate gravity on this spinning space station. Okay, first off, what are we looking at here?
Yeah.
So the space station is spinning. This is a particular shot where we're sitting on the space station watching the stars rotate. And I'm going to follow our particular star, this one right here, and we're going to watch it go through a quarter rotation and figure out how long that takes. And this is going to give us how fast the space station is spinning. Okay, so when this star right here crosses the vertical line, we're going to start the timer. And that's going to march its way over here. And when it crosses the horizontal, we're going to stop the timer.
Sounds good.
So here, crossed, starts timer. It's going.
Okay, it's moving.
There it is, right there.
Okay.
Okay, still going.
Coming along.
Here it is, there it is. Almost. Bam. Okay, so 15 seconds. It went through a quarter revolution.
Okay.
All right, and there is a little bit of stretching here. It's not a perfect circle because the camera's zooming out.
Yeah, okay, yeah. If you're zooming out, it's going to change the length of the circle.
Right. So there's some bending going on. If we keep going, you can see this is inside the space station, and here's the craft coming to line up with the center of rotation, which it does.
Cool.
It's pretty cool.
Okay, so the stars are staying still. They're super far away. They're staying still. So the spinning is because the space station that we're on is spinning. And you said that in a quarter rotation, it took 15 seconds. So it's one rotation per minute.
Exactly. So I calculated the spin rate. So we know if it's 15 seconds per revolution, it's going to be one revolution per minute. Easy. But we need that in radians per second. So that would be
revolutions.
Yeah, don't work. Only for intuitive gut checks.
Okay.
So the spin rate, which is in radians per second, which is the change in radians divided by the change in time. Pi over 2 radians for 15 seconds gives us this.
Okay, yeah.
Okay. All right. So the next step is we've got to figure out how big the space station is. Okay. So what I did is I figured out, so we have a human scale here. Yep. We have a size of a floor on this human scale. And then I looked at the space station picture, and I saw there's one floor.
The windows and lights? Okay.
And there's 3 floors, about 3 floors. And I'm saying these row of lights is 1 floor. Second row of lights, 2 floors. And then there's no lights here, but it's about the same size, 3 floors.
That's about... Okay. I'm with you. And then how tall is a floor?
So how tall is a floor? So for one level, I looked at, this is a person, this is a man.
Yeah.
And I said there's probably some floor space, and then the space where people walk, and then a little bit of floor space.
Like a drop ceiling with all the electrical goes. Okay, I'm with you.
Yeah. So I'm saying, if I'm looking at this picture, maybe it's 1.5 from bottom to top of the height of him. Okay.
Kind of reasonable, yeah.
So I said the height of one level is 1.5 times the height of a man.
Okay.
And I looked at the average height of a man, 175 centimeters. Sure. So 1.5 times that is 2.6 meters. Okay.
So that's the height of a level. Sure.
And so then the height, if I go over to this picture, which is dead on, which this red line here should be about 3 levels.
Okay. Yeah, I agree.
Okay. So if one level is 2.6, I multiply it by 3 to get the total size of this red
section. Of that red line. Okay, yeah, I'm with you.
Yep.
3 times 2.6, whatever it is.
Exactly. And what we need is the radius. I did a diameter so that we can stack a bunch of these together. I'll show you what I mean here. So I stacked. This is the height that we know.
Okay.
And then this is the diameter.
Right.
I dropped it perpendicular. So you just got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And some
0.6.
Okay, yeah.
0.6?
Sure,
0.6?
Yeah.
Okay.
Yeah.
So to get the radius, I take the diameter and divide it by 2. So I got 11.6 of the red lines.
Sections.
Exactly. Times 3 times the height of one level.
Yep. Yep.
Okay, divided by 2. So
Divided by 2, that's the radius.
Yeah. 11.6 divided by 2 is 5.8 times 3 times 2.625, which I got from the previous calculation, gives me about 45 meters. So the radius, which would be the distance from the outer here to the inner here, is 45 meters. So 90 meters in diameter. Actually kind of small.
Kind of small, but also I don't know what a space station was. Sure. So if that's what you got, that's what you got.
Right. So now we're ready to calculate the centripetal acceleration, or the equivalent G.
Sounds good.
Okay. So we know that centripetal acceleration is v squared over r from your physics textbooks.
That's the tangential velocity divided by the radius.
Yep.
Okay, sounds good.
And there's a formula that the tangential speed is the angular speed times the radius.
So if I have a fixed angular speed with a larger radius, then the velocity goes faster. Okay. Yeah.
Yep.
Yeah.
So I plug that in, cross out the r's, and I get omega squared r, which is also a formula. I could have started here. Oh, well.
Now let's derive it.
Yep. Okay, so I plug in my numbers. I've got the angular speed in radians per second, and then I've got the radius. Multiply those together, and I get 0.5 meters per second squared, which is pretty low.
That's soft. That's super soft.
Super soft, right? So that's 0.05 of an Earth G. So you're going to be bouncy in this.
Maybe that's why in the movie they say that your socks explicitly have like grip texture.
That's right. But I think this space station is designed so you don't need that. I think they're wearing like business shoes. Is that right?
Yeah, they're wearing dress shoes. That's a good point.
Dress shoes. And I think you would design this to be maybe 0.5, maybe close to 1 Gs, like something comfortable, right?
Oh, yeah. In fact, that's a good point, because if you are too far away from Earth G, then the human body doesn't maintain its musculature, doesn't maintain its bone density. So for the human factor, you want it to be close to Earth.
I think so. So, which means I think this calculation is wrong somehow.
Oh, okay.
And my guess is, so I don't think I messed up the rotation, because we got that directly.
Yep.
And it's being 15 seconds perfectly for one rotation. That seems too good to be true, which means it was designed that way.
Oh, I see what
So
you're
I'm
saying.
guessing, yeah, like 1 revolution per minute. Let's just stick with 1 revolution per minute. Sounds good. Which means I think my radius calculation is too small. It's too small. And I think it's maybe this picture that's throwing me off. It looks kind of small if I'm looking at it. Whereas if I look at this picture, it looks big. And if I look at this picture, it looks real big. Like this is the landing bay, and these are people. These are people right there. People.
Can we see for the landing bay in your measurement picture, how many red sections is that?
That is okay. Let's move a red.
Like
let's move the red here. Let's move the red.
2.5.
Maybe 1, maybe 2. Let's say 2.
Maybe 2.
So
if a red section we said was
it was 3
2.6
floors.
meters times 3.
Yeah. And that is 2.6 times 3, so that's roughly 8 meters. I think
24 feet, something like that.
Yeah, this is more than 8 meters.
Oh, that's way bigger than that. Yeah, that's way bigger.
Right. So go ahead.
Sounds like that middle picture you have, the picture immediately to your right. Sounds like maybe there's some distortion in the camera lens when this is taken.
Maybe
something like that.
Maybe I got there's 2 rows of windows plus 1 more. Maybe those rows of windows don't represent a floor, could represent multiple floors.
That's true.
That could throw it off.
I wonder if this was to scale, would this ring be like out of the picture?
Maybe. Yeah, it like in order to get this particular shot, they had to compress the look.
Exactly.
And so that threw it off. Yeah. Okay, it was a fun calculation though. But I think gotta pay attention to your scales, when you do these kind of calculations. If you do these calculations all the time, which we do. So I think
very cool.
Probably they were shooting for something like 0.5 to 1. So in order to increase that to 1, we need to multiply this by 10. So we're looking.
So you'd have a much bigger ring, and that's also good because then you get more space available. I guess you just have to have more mass to bring it up into space.
Yeah. And actually, now that I think about it, if we want to get this to be 1G, so you got to multiply by 10, which means you're multiplying this roughly by 10, which is about 500 meters, which would mean the radius they designed this for was about 1 kilometer. Okay. Now we've got 1 revolution per minute and 1 kilometer. Those are pretty reasonable numbers. And then if you're on the inner part, you're not feeling the full G. It's only on the very outer edge you're feeling the full G. Right. So maybe in these compartments, you're sitting at like 1G for 100 meters across. 1 kilometer diameter and 1 revolution per minute. That seems reasonable.
Sure.
Okay. So I think this number's off.
Yeah, reasonable. Yeah, so calculation, you had the correct equations, the theory you had to get there, but then in the measurement, which was challenging measurement, maybe there's iffiness there. But okay.
Iffiness, yeah. Okay. All right. 2001 made a lot of future predictions, and some of them are right on the money. Mostly.
Please state in the following order your destination, your nationality, and your full name.
Moon, American, Floyd, Haywood R.
Thank you. You are cleared through voice print identification.
Wait, so what does this have to do with future predictions?
So what, in the 60s, 70s, 80s, 90s, when you were at an airport, you would like have the paper boarding pass, and they would you'd show it to them, and they'd be like, get on through. And in the 60s, they made this prediction that instead of having a boarding pass or instead of having an ID with you or passport, you stand in front of a camera, like I'm doing right now, and it does like some sort of voice recognition and image recognition of your face and lets you on through. There's no paperwork. There's no showing identification. It just knows who you are.
And is that what happens now?
Yeah. Oh, I just did this because I have global entry to get into the U.S., So you go stand in front of a camera and it's like, hello. And then it tells you who you are. Hello, how you doing? It tells you who you are, and you don't have to show your passport.
I see. So instead of checking your passport, it's doing some type of facial recognition, maybe voice recognition. And then it just says like, I've seen this person before. All right, this person is connected to this passport, and they're good. They're good to go. Go ahead and go through. So there's no like flipping through your passport. Oh man, I hate it in line when the person in front of me doesn't have their passport out. It's like you knew which line we were in the whole time. You could see people doing it in front of you. And you're saying now you don't got to do that.
Don't even got to do that. And they predicted that in the 60s. Incredible.
Interesting. Yeah.
And
that's some foresight.
In fact, we're not quite there because when I went through the airport, I didn't talk to a computer. I still had to talk to a human and be like, where are you going? But maybe I could see it. The next step is they do the recognition of the face, plus the computer can ask you a few questions about where you're headed, where you're from, stuff like that. And that would be exactly this.
I mean, heck, even further in the future, as soon as you walk in, they just recognize who you are. You go to McDonald's, go to whatever your coffee it is, and you just go onto your plane. You don't even have to talk to a person. No check-in. Just walk through. They already checked you in.
Just walk through. They already know, yeah. In fact, I guess we're going to do with stores and stuff. You just walk in, walk out. No problem.
All right.
That was that Amazon thing, but apparently that was fraud. I don't know.
Apparently that was problems with it. Okay. Tech needs to catch up, but the vision is there.
Vision's there, right? And there's more. Oh, this one. This one's also the back in the 60s, imagining having video on the back of your seat on an airplane.
A personalized television. Heck, even in the 90s, maybe 2000s, like you didn't have your own television. You had like the one television that was in the hallway and everyone had to watch the same thing.
Right. I think 2000s, maybe this was starting to come into, but it was pretty rare. But now it's pretty widespread. And in the 60s, no way. Like, what a prediction.
Foresight. Yeah.
Now, also one of the things they do here is like, the screen is big.
Big screen with
only a few buttons.
That's right.
Right? They don't have this like a little screen. Cool predictions. This blew me away. They predicted iPads, tablets.
That's right. That's what that is.
That's what there's a tablet, right? Right there.
And just like you said about the TV, it's the video section, the screen portion is enormous. And like tiny little buttons at the bottom. Not like how we had these handheld video games where it was like mostly buttons and like a tiny little screen. No, this is opposite. This is big screen. Like maximize the screen area. So they also understood what our values would be, like what would be important in these tablets.
Right, because I think in other sci-fi series, when they have like tablets or sort of iPad tablet equivalents, there's too much bezel. Bezel is
That's the word.
the outside shell edge thing.
Right.
And there's too many buttons, and it's all awkward. Today we just have make it big, screen, and they did this.
2 buttons.
One
That's
button. Right. They only have a few buttons. It's not like they put like a full keyboard or something on here. Like way too many inputs. So this is awesome. Like what a prediction.
That's some vision. Yeah. Called it.
They called it. Yeah. There's some more.
They called this too. Check out. So see that hotel room? Howard Johnson's.
Howard Johnson. That's a chain.
It's a hotel chain, right? Yeah. So that's like the combination of private industry working into space.
Right, which I guess we don't have just yet, but this kind of do with SpaceX, and we're getting towards privatization of space travel.
Exactly.
They're saying full like hotels in space, like the chains.
And given at this time it was 1968, so all of space stuff was purely governments. It was like governments fighting other governments. But then here they had the foresight. It's like private industry is going to get involved
eventually. Yeah, by 2001
more
for
picture.
sure.
Look at this guy. It's the same thing, but it's like just the Hilton.
The Hilton.
Hilton's going to have hotels in space.
So we got Howard Johnson in space, Bell Telephone in space, Hilton in space, and who knows what else. All kinds of stuff. I was also blown away. Maybe this is coincidental with our time. Just the interior design look feels like I could walk into a hotel today, and this wouldn't be that out of place with the weird chairs and like the straight lines with the right angles. Hell,
this,
even
like,
this font.
That's right. Very blocky, very simple, very like straightforward. None of this highly stylized, kitschy stuff.
Right, like the curlicue stuff they used to do.
Too hard to read.
So cool.
Yeah. That's some
Also,
vision.
look at these flat screen TVs. Those look like flat screen TVs. And it's
That
like
looks like fun.
massive TV. Just bam.
And back then they had these big old thick, like 3-volume cathode ray tubes. So like these big volume things, like super heavy glass. But then the 2001 The Space Odyssey, the people, they envisioned that they would be flat. Like why they predicted that we would get rid of the mechanism in which cathode ray tubes worked. And we condense it down to flatten it.
Right. And then they had the foresight to be like, well, if it's flat, make it big. Because it almost fills up the whole hallway in height terms.
Yep.
So cool.
They also predicted in this movie that there would be Jupiter in the future. And it's still there.
It is a prediction.
It's there, right? You look up in the sky, it's there.
I predict next year Jupiter will still be there.
Will you be right? I think you will. And this eye thing, this is the HAL 9000. They predicted that in the future we would have AI stuff that would look like this.
Exactly.
And I've seen it.
There it is.
Right? I've seen it in other movies. So they predicted that we would have this movie called Up, and Wall-E, and then here would have these enemies, this bad guy there, that had a very similar look to it.
So you're saying in 2001 they anticipated pop culture in the
2001, the movie, which was filmed in 1968.
Yep.
They predicted that our pop culture in the future would have this guy that looked like that's also the evil AI.
That's right.
Pretty good.
I mean, this is a general look for AI. That's how AI looks. There's no other way to do it.
I mean, no. There's lots of ways to do it. Yet still, the filmmakers predicted that it would look like this.
They knew it.
Incredible. I think they have a natural solution for kids not running.
I got time for breakfast?
Oh, I think we can manage that.
How long have I got?
Your flight leaves in 1 hour and 10 minutes.
Okay. What are we talking about?
Did you see it?
Kids
So they're just walking around on the side of the space station, but see how it's curved? See how it's curved and how their heads disappear when like beyond the horizon?
Yeah.
I think that's a natural deterrent for kids running too fast in the hallways.
Okay, so you're saying if there's kids up here, they're running, they're going to feel uneasy because they can't see forward?
Exactly.
So they're going to
when
slow
you
down?
can't see, right, they'll slow down, at least they'll back off of full speed. when you can't see what's in front of you. Like I don't drive full speed if I don't know what's in front of me. But if I have like clear vision for miles and miles and miles, like, okay, I'll let her rip. But because of the curved space station, because of this ring structure, because of the ceiling is so low, you can not see so far away, which I think would naturally limit kids like running around inside the space station. Which I want a neat, orderly space station. I don't want kids running around break stuff in space. We got big problems.
Okay, counterpoint.
Okay.
Kids do a bunch of dangerous stuff. They don't know it's dangerous.
That's right. They need to learn.
They're going to run full speed. I can't see. I can't see. I'm going. Also, what is the distance that would make you feel uncomfortable if you were sprinting? Like, is it 10 meters?
I guess it's my stopping distance and my reaction speed plus some buffer.
So, I guess 5 meters is pretty uncomfortable. No way.
Yeah.
10 meters, still pretty uncomfortable.
30 feet-ish, something like that.
Yeah. So, probably want...
I want to say 11.
Oh, 11. Okay.
Yep. If I can see 11 meters in front of me, I'm free to full speed. Okay, no. It depends on what's also around me. Like, what are the dangers? Like, if the known dangers are things like cars that I know can go fast, then I need to see further away so that I can get more warning to stop.
That's right. If it's like a video game and there's like spikes and crushers everywhere, then I need a lot more space because I don't just want to run and get crushed.
Right.
So
but if it's just a field full of bunnies, like, let it rip.
Let it rip. Exactly.
And what are they going to do?
What would bunnies do?
I mean, I guess you could trip on them or roll your ankle because they're very soft or something. Mm-hmm. Yes. So, okay, but I think there is a problem with this. So I think humans have problems when they cannot see far away. Like, you get this, not exactly claustrophobic feeling, but you feel like I'm trapped in a box. I guess that's claustrophobia. Yeah. So because of the curved space station, you can't see far away, and I think that would cause problems to human psychology.
So you're talking about like a cabin fever,
exactly,
sort of thing.
And I think this might address it. So this is the Metropolis station, the something station.
Heliopolis.
Thank you. Heliopolis station, and I think it was Gundam Seed. One of the Gundam Seeds.
Yeah.
And so you build these tube colonies. So that way the inside is hollow, then you can see far away.
Okay. So that looks like this.
Exactly.
So there's actually like farmland here with like cities built up. Mm-hmm. And it's all sitting on the outer shell, but the inside.
Yes.
And so it's got this artificial gravity as it rotates.
Mm-hmm. And so you solve this problem where you get people feel like they're trapped in little tubes. Like, yes, we're in a tube, but it's a big tube. It feels big and open. It feels like you have freedom of movement. And I think there's also issues of like if your eyes cannot see very far away, they get lazy and then you need glasses. And so with a space station like this, big, long tube, people can see inside. And then I think that might solve that.
I think so. So like this picture over here, super low ceilings. You can see the curvature. It's very, very like, I feel confined.
Too tight.
It might mess with my head.
Yep.
Whereas over here, I can like almost literally walk outside.
Yeah.
And I'm in farmland. And even if I'm like looking at the space station, the shell above me, it like feels like open space.
Feels far away. Yeah. I don't feel, at least on human scales, I don't feel constricted.
Right. Highest ceilings of all time. Oh, cool. There's like cables under tension holding this together. That's cool. That's a cool little. That's
good
cool.
detail.
That's a target. Hit it.
Okay. Terrorist.
Wouldn't this flight attendant feel super sick? She's got her Velcro shoes on. Mm-hmm. She's going in a circle.
How's she doing that?
So my first thought is, if you've got a rotating something, the center of rotation's in the middle.
Yeah.
That means gravity for her feet is down, and gravity for her head is up. So you're like, whoa. Which way am I going?
You're feeling like,
right?
oh gosh, you're feeling stretched? And your inner ear is like, my feet are telling me something different than my head.
Right. My head's like, I'm falling this way, but my feet are falling the other way. Like, I'm like, ooh. Right? It feels super. Yeah, right?
Yeah, I guess. All right.
Right. But then,
Although
I
I
was
wonder,
like, go ahead.
Would you get used to it?
I think you get used to it, though. Like, at first, it's like getting seasick. I think something like that. You get seasick, but if you're like on boats all the time, your brain is going to be like, this is normal. Stop freaking out. Right?
That's right. That's right. I guess you get your sea legs. You get used to it.
I think you get used to it, yeah. So maybe at first it's like, bleh, and then the vomit goes both ways. But I also did think of it. We're not on a spinning ship, so I thought this. Now that I thought about it, it's actually pretty weird.
Wait, where are we?
We're on this ship,
Oh, the transport ship.
the transport ship that's
No.
going from the space station to the moon.
Down to the moon. That's right. That's right.
And the design of this is not rotation at all.
That's right.
In
It
fact, if
doesn't
we look
spin.
at the passenger compartment, which is right here, where our boy is sitting, this is on the base of the spaceship, and the engines are underneath. So when it's accelerating, you get gravity into your chair.
Yeah. Okay. That feels good. That seems right.
So
Yeah.
in this picture, so this picture right here, they're sitting on the base, and when these engines fire, you get gravitated into your seat.
Right.
Right?
You get held down to your seat from the acceleration of the ship.
Right. Right. But then that doesn't make sense with this picture.
Okay.
Because
How so?
well, it's not a rotating ship. So if you're not in a rotating ship, you're in
Then
zero
the-
G.
the-
When
If you're not in a rotating ship, you're using gravity via acceleration. That means
Right.
the entire ship feels the same acceleration, so therefore the gravity should all be in the same direction.
exactly, should all be in the same direction. But that's only true when the engines are on.
True.
If you turn on the engines and then turn them off on your way to the moon,
You're coasting.
you're in zero G. You're coasting.
That's
You're
zero
zero G the whole time. Right? It would be ridiculous to turn on the engines the whole time. It's a lot of fuel.
Yeah.
Because it takes quite a while to get to the moon. So if the passenger compartment is designed for the passengers to feel comfortable during the acceleration, which gives them normal Earth gravity into their seat, and this is on the base of the ship, which means gravity is going from the front of the ball down to the base of the ball.
Donald. Yep. To the base of the ball.
Yep. And that means that first off, the pilots are in a weird position where their acceleration is like backwards into their seat.
I guess that pushes them into the back of their seat, but getting onto their seats before takeoff would be super weird.
Right. And don't have like a cup of coffee like next to you sitting there because it's going backwards.
Yep. Agreed.
So that's weird. And the engines are not on. So I feel like the flight attendant, if this was like the procedure some egghead made up, was like, just use your Velcro shoes to do this. I feel like she would eventually just be like, float up to here.
Just grab
And
on.
then
Just grab onto
just
the
grab
wall.
on.
Why am I
So
doing
what-
this walk around sequence when if I'm in zero G, I can just float to the corner?
Float to the corner. In addition,
Also, yeah,
Go
go
ahead.
ahead. Yeah, I think you're going to say the same thing.
yeah, the elevator here is up and down, which we
Yeah.
see in the passenger compartment. Here it is, up and down, which means
Yeah.
the pilots are sitting at either 90 or 270 degrees from this vertical.
Yeah.
And she walks parallel to the elevator to anti-parallel to the elevator and goes and talks to the pilots. That can't be right. Right? I think I have a picture here. Yeah. This is where she walks. So she's still parallel or anti-parallel with the elevator and walks into the pilot's cabin? What?
And but according to that picture where you can see like the red pilot's cockpit,
Let's go this one.
they're sitting, which means they're like looking forward. They're not like looking out from the ceiling, which means
Right.
that from that picture where she's in the hallway, they're laying down relative to her. And so she
Right.
like walks into the room upside down. Yeah,
Upside
she
down.
she went too far.
Right. So she's going to go only 90.
Yeah.
Right?
That's the way to get out. 90 degrees, because then she lines up with them who are sitting from their perspective normally, which is from everyone else of the ship, 90 degrees.
Right. So vertical is like this for the elevator. She should rotate 90 degrees and then walk to them.
Yep.
She just
That's right.
she rotates 180. She's just flipping herself over. She's still not oriented with the pilots.
That's right.
What in the world?
What is happening?
Yeah.
This is a plot hole.
Plot hole.
Plot hole. Rest of the movie. Can't watch it.
Can't watch. Okay, so I think it's just hard to get good intuition for zero-G environments. It's just easy to mess stuff up. If you're in the zero-G environment, I think you immediately start putting like things
Your
together.
brain would get used to it.
Right. Brain would get used to it and start thinking in 3D and rotations and different things.
Enemy
But if
gauge
you're
is down. You figure it out.
Yeah, sitting on Earth making a movie, I think it's hard. You got to keep everything straight. It's hard to do.
Yep. I think I've seen this playbook before.
Congratulations on your discovery, which may well prove to be among the most significant in the history of science. I know there have been some conflicting views regarding the need for complete security in this matter. Your opposition to the cover story, created to give the impression there's an epidemic at the base. I found this cover story personally embarrassing myself. However, I accept the need for absolute secrecy in this.
What do you mean the playbook?
I mean, that sounded familiar, right? Like there's a scientific discovery,
Okay.
and then there's a need to cover it up. And the thing that they use to cover it up is some type of viral epidemic.
Okay, so what you're saying, in our world, there's a scientific discovery that we don't know about that was covered up with an epidemic, some sort of pandemic?
I mean, pandemic if it's everywhere, but if it's localized to an area, that's an epidemic. And you say, everyone in this area is sick. We got to close it down, shut it down. Secrecy, control, police. Right? Isn't that what happened here?
So if I'm on Earth in the 2001 scenario, the news comes out that there's been a flu outbreak
Yep.
on the space station, and that's all I hear. And it was locked down for a while, and then it's not locked down anymore after the flu dissipates.
Yep.
And hopefully it doesn't come to Earth. And I'm none the wiser about this alien discovery. Is that right?
Yep. That's exactly right. That's exactly what I'm saying. And during the time where there's lockdown, there's like lockdown all the people in the base, and they're not allowing them to communicate to the outside world. And if they do dissent, they're like, no, we're going to lock that down. You're not allowed to dissent either. And so they like, under the auspice of there's a pandemic, there's a flu. I guess they said epidemic here because it's localized. Under the auspice of an epidemic, we can use that to lock it down, control everything.
So you're saying in 1968 when they made the movie,
Yeah.
they knew that in order to do a good cover-up, you got to do a pandemic or epidemic cover story for something pretty extraordinary.
For something pretty
And-
extraordinary. So what really happened?
What really happened? Okay.
Don't know.
I mean, it's a good way to cover it up. It's a good
That's
way
right,
to
'cause-
it's a good way to cover up, because if you need to lock something down and you say there's an infection, what's the first thing you do with an infection? Quarantine. It's the same thing as a lockdown.
What do people outside the quarantine zone do? They're like, I don't want it. You guys are sick. You guys handle it. You guys do your thing.
Yeah. So actually, if you need to cover something up, a pandemic or epidemic is a really good idea. It's distracting. It's scary. Lockdowns make sense.
What really happened in
Okay.
1919?
1919.
Isn't that Spanish flu?
Oh,
Maybe
true.
all the pandemics for all the history have always been alien cover-ups.
that's right. That one Roman pandemic way back in the day, it was aliens.
What happened to the Romans? Aliens.
Aliens. I mean, according to the History Channel.
Aliens. And it's more convincing because why won't they tell us what's there?
Now, I'm sure you're all aware of the potential for cultural shock and social disorientation if the facts were prematurely and suddenly made public without adequate preparation and conditioning.
So what's your question?
My question is, even if so in 1968 they made this film and they predicted in the future that if there were aliens, if there was evidence there were aliens, the government would say they're not going to share it with us. They're not going to share it with us because humans wouldn't be able to handle it.
Okay.
But humans are so good now, we can handle it.
I mean, I agree with that. I think
I disagree with that.
So I think if it came out to light that there were aliens somewhere in the universe, I think people would be like, and then they would just go back to their regular day. Like, what are they going to do?
Massive
Like, do I not
looting.
go to work?
Massive looting. Not people not
Why?
going to work. I think it's because people have a worldview that we're the only ones around.
Okay.
And we're therefore the best. Or there's a bunch of religious institutions that say we're the only ones around and we're the best. And to shake that up, to say that there's aliens, I think that would be like world just big old shake up for lots of people. And then people are like, this is crazy, this is chaos. And in that chaos, I can take advantage. I think that would happen.
I'm not sure. But I get the feeling it would be a little bit like, the new Jurassic World movies where everybody's like, oh, dinosaurs. And then after like 20 minutes, people are like, whatever, I'm just going to gossip. I'm just going to, live life. And like dinosaurs, whatever, they're now part of the world now.
Like, everyone's back on their phone. Like, whatever.
Everyone's back on their phone. I mean, phones are addicting. People are like, aliens, there's phone. That's,
but
I don't know.
media.
I don't know. If I want to loot, but if I heard aliens, am I going to think, if I go loot that store, am I going to get away with it? If
this is the time when everyone's looking up and you're looking down at the 7-Eleven.
7-Eleven?
Yeah, you can get some real
I'm
petty
looking at the
cash.
Zales.
Real petty cash.
Real petty. Damn, that row of Cheez-Its is mine. They said aliens.
I've been looking at them Cheez-Its for years.
Those Cheez-Its. Get the Pringles too. Save me $50.
I mean, yeah, right? But that's okay. But also, you're joking. But also, that's a crime they're not going to prosecute. Not going to prosecute.
I mean, okay, it's only if everybody else does it. If I hear aliens in the news and I'm like, let's go loot, and it's only me at the 7-Eleven, then I'm just shoplifting, right? So my prediction is that they would say aliens and people are kind of freaking out, but then they go back to normal life. There's not widespread looting. Are you saying that people would say aliens and then everyone's like,
massive
let's go smash? You think
massive killing,
looting?
bad stuff, real quick. I think real quick people go bad, and then maybe eventually they recover. Maybe eventually it's like it settles down, and we're like, okay, we still got to go on with life. But I think right off the bat, bad stuff.
Okay. If it's like an Independence Day scenario where like the ships come down and like they're here and like mess, then I think maybe some looting. But if
I
it's
think
like
actually that's a situation where there's no looting.
What?
Because if aliens are here to kill us, what am I going to do? Steal a TV for 7 days?
Yeah.
I'm gonna. This is my chance. I'm gonna subscribe to every streaming service, watch everything for the next 7 days. I'm not gonna pay that bill. The whole planet's gonna die. That's not worth it.
Yeah, you stop paying bills. You stop going to work. That thing you've been eyeing at the store, you go get it. Because you're gonna die, or at least you think you might.
That's a good point. I think you've convinced me that riots would happen.
But what if it's like we discovered there was an alien artifact on the moon? We dug up. We're really not sure what it is, but it's definitely alien. Now riots?
Okay. But what if it came out that I see what you're saying. But what if it came out that we found an artifact on the moon and the government had been lying to us for 50 years? Now there's distrust in the government, civil unrest, loot. Right.
Isn't that today? The government lies to us. There's all these conspiracies that came true, like MK Ultra and whatnot. And people are just like, whatever, I got work, right?
Shit, that's a good point.
But what if like MK Ultra is bad, but it happened to like a few people? What if it's like a major lie, like aliens? I don't know. Like, is there a lie big enough that if they found we found out that the government was lying to us? Is there a lie big enough that would make us be like, you know what? That 7-Eleven looking real nice.
That 7-Eleven's mine now. Maybe.
I'm leaning toward no. There would not be riots. I don't. Just a feeling. I don't know.
Maybe we'll see.
I don't know. So, but
we'll see when the truth comes out. Place your bets.
Place your bets.
Yeah.
Yeah, there might be a betting website where you can actually place bets on that.
Yeah, why not?
Maybe. Why not? They'll take your money. Why not?
In this movie, they're a monoliths, but what are they and why are they 3?
I don't know what the monoliths are. So in the
aliens for sure, right?
Aliens for sure, right? Some kind of
Yeah, alien stuff.
And they built them, and then they placed them one on Earth,
like overnight. It's like boop, here it is. Boop.
And then they booped one on the moon, but let it sit there for a while.
Yeah.
And then they put one in orbit of Jupiter.
And they
is that right?
They put it on the moon. And okay, let's scroll to the side.
Let's go, scroll.
So there's one by the monkeys, and like these guys, like wake up in the morning, like, oh my gosh, it's new. So like it's overnight. It was just dropped there, right?
Yeah. And
then on the moon, and so not on the moon, but not only on the moon, not on the surface, but they buried it.
Right. There's no on the moon. There's no movement of sand and erosion and stuff like that. So it can't be placed on the surface and then buried. Moon's pretty static. So they buried it on purpose.
Yep.
And then Jupiter.
In the Jupiter section of the movie, there's one floating out in space.
Okay. Does that mean there's at least 3?
There's at least 3.
There's at least 3.
It could be more, but there's at least 3.
Okay, so I thought it was heavily implied that the monkeys saw the monolith and that one monkey was like, tools! And that idea was seeded by the monolith.
I think that's exactly right.
Okay.
So he takes the bone of a dead animal, and then he's like, I can smash things with the bone. Like, I figured out tools. But it's actually the monolith gave him a little burst of intelligence, maybe a little vision of like solid object thing. Oh, it's hard. Okay, solid objects. I should see what else is solid objects. Maybe.
Yep. So that kicked off like the intelligence revolution.
Okay.
And then maybe this one is like warp technology in Star Trek is like an indicator that a civilization has like made it,
reached a level.
And so maybe the aliens level is if you can get to the moon and you can dig up this thing, then you've passed. Maybe.
So it's the first one's like, here's a little bit of intelligence. Okay, here's a little bit of brain for you. Go evolve. Go figure some stuff out. And if it's evolution works on that planet with a highly oriented intelligence motivator, if you guys can get off your planet, you can get to your moon, you can find this thing. Like, hey, you guys are pretty good.
Yep. Maybe because like as soon as they dig it up, right, it says it sent
a pulse out to Jupiter.
To Jupiter.
Yeah.
So the aliens figure we can go find it.
Okay. And then they go find one. And then this one is like the relay that sits outside of Jupiter orbit.
Yep.
And then sends messages to the aliens, I guess.
I guess what whatever species makes it to this one that's at Jupiter, this monolith sends the guy through, whoever it is, the group, in this case just one guy, through the wormhole to the alien civilization. For some reason we don't understand.
There's like different level of tests, and then for some reason this one is farther away. Even though I guess I would argue that the difference between getting to our moon versus to Jupiter is not that big of a jump compared to the first one.
Right. So first jump is what, Tool to moon. That seems huge, but then moon to Jupiter is like kind of not that big of a jump.
Can you do a bit of engineering and resource management?
Right. Just like up your rocket game a little bit, up your life support game a little bit, and you're fine.
A little bit, you're fine.
So weird.
But yeah, it seems reasonable that that's what these things are. It's like they're markers for different stages of evolutionary success.
I think so. Maybe.
Except for the first one. The first one's like, here's some brain. Go think about stuff.
Let's check out the engineering of the Explorer 1. What do you think?
Seems like a ball with a stick with the satellite dish. Is that what you wanted?
I mean, okay. In simple terms, that's it. There's a ball. There's a stick. There's a satellite dish, and then there's the engines.
The engine is like a broom handle type engine, little fan out on the back. Okay, what I also noticed this. I'm glad you brought this up. I really like the satellite dish is pointing backwards.
Why is that?
Because if we're traveling towards Jupiter, then back behind me is Earth. That's who I'm transmitting to.
That's a good point. So yeah, so if you're vectoring away from Earth, then the satellite dish should point backwards. Maybe with a little, I mean, it might not be visible
Like
actually.
small adjustable. Yeah, sure.
So if it's the vector of velocity is this way, then Earth is that way. Yeah, good point. So I guess what is the design here? There's the forward part, which is life support. Then there's like cargo.
I think that's right.
And then the satellite dish is in the middle. And then there's engines.
Yep.
And then this is like fuel and stuff.
Yeah, I guess so.
And it looks like anytime they need to do maintenance or check anything, they need to go out in one of the pods and go actually look at it with an EVA.
Ooh. So it's
Instead of
not
having an
atmosphere
internal?
linked all the way through. Yeah, it's not an internal hallway.
Yeah, I would want make like a big, maybe there's air constraints. I don't know. But put atmosphere all the way through so I could shirt sleeves check it. Right?
Yeah, I don't have to put on a suit. I can just wear my regular t-shirt, just walk away all the way through.
Right.
I guess the problem with that, though, is that if there's any punctures from space dust, then it's like atmospheric leak, like close all the hatches. And that's additional mass to have hatches. Whereas with what you're saying is true, where the middle section doesn't have any air compartments, you only need a hatch for the front ball, and the rest outside is all vacuum. Who cares?
Yeah, so there's mass concerns. So if you start adding atmosphere, then you've got to add bulkheads, then you've got to add lots of additional
Mass
air
and complexity.
and complexity. Oh yeah, the complexity. Yep. Which you say, okay, the humans can handle the complexity. They just go out and check. Not a problem. Yeah, it's a little bit more challenging, but they got it. They're trained. It's fine. I do like that the crew compartment and the engine compartment are as separate as possible.
Always
So if there's
possible,
So if there's a problem over here, then they're fine. They can deal with something.
Okay, but counterpoint. So if it explodes, then that's great because then the people are far away, which means they're less likely to die. However, if the engines explode, the people are just drifting in space. They're gonna die anyway. So you might as well have them close so they can handle any problems.
Maybe okay. That's true. But okay, what if it's if it's like the engine goes through a failure but not critical? It's nice to have the separation. If it's like a blow up, then you're so screwed anyway.
If there's
But
a
if they're
failure,
real
it's like
close-
radiation zone, then it'll keep them far away.
Yeah. One of my big problems was the satellite dish is in the middle. It's getting blocked
problem?
by a lot of the fuselage or whatever you want
I
to
see what
call
you're
it.
saying. I see what you're saying.
You could actually free float it out here and run a cable.
That's right. There's really no reason for the satellite dish to be so close to the body. And if you how do I say this? If you draw with your mouse the cone that comes out of the satellite dish,
Yeah.
bam, hits the ship right away.
Hits the ship, right?
Yep.
I mean, I guess it's shooting directly this way, but if it ever had to turn and look this way, the orientation of the ship got weird.
In the way, not good.
Maybe it's okay. I'm not sure.
And I'm guessing this thing is built in space anyway. So there's really no problem with just building it further out. And as you said, attach some little cables to the front and then and the back, so that way it doesn't feel lots of torque.
Yeah.
I think that'll work.
You have some load point, so you just when you're gonna burn the engines, you bring it back in.
Okay,
But then if you have to do an emergency burn, suddenly, and it's dangling out there. Now you got problems.
Now you got problems.
Hard to say. Cool ship though. I like it.
Yeah.
A lot of good, scientific based engineering principles at work. I like it. I like the design. Wouldn't this guy feel sick on Discovery 1?
Wait, why would he get sick from that?
So on Earth, we're feeling gravity down, and it's down everywhere.
Yeah.
So everything's cool. And it's the same at my head as it is at my legs. Everything's cool.
Feels uniform. Yeah.
But this is a pretty tight cylinder. And so he's spinning it fast. He's feeling down for him is different than down right in front of him, different than down behind him. There's a difference between gravity at his head and his feet. Would he be whoa, woozy?
You're saying he would feel more Earth-like if this was a larger ring, a larger circle, such that there wasn't such a large angular difference between where if you put his hand out in front of him, that gravity is
Yeah.
pushing down and away from him, actually,
Yeah.
because it's always
Yeah.
radially outward. Interesting point.
Or would you just get used to it?
Probably you would adapt. Probably eventually, like give it enough time, you'll adapt to it. But
Yeah.
probably for a while, it feels pretty sick.
So I did some. Go ahead.
I was also thinking about the rotation speed. What's a reasonable
so
rotation speed?
Yeah. So I did a calculation on this, and
Hell yeah.
I couldn't get everything I wanted in terms of the calculation, so I made a table. So the first thing I did is I directly measured the radius of this cylinder based on the height of this man. I mean, there's some perspective stuff going on here, so this is a pretty rough estimate. But if this is an average man, and then this is the radius of the cylinder, I can do the same. I can do a stacking. So man,
One,
man,
two,
man,
three.
man.
4-ish. Yeah.
So 1, 2, 3.8
Yeah,
equals
okay.
one radius.
I buy that.
Okay. So the radius is 3.8 of the height of a man. 3.8 times 1.75, average height of man, is 6.65 meters. That's the radius.
Okay. Yeah, sure.
But given this these shots in the movie, there was no way to figure out the rotation rate because we're always shooting relative to the rotating drum.
Yeah, we follow the guy. We're not stationary, and then you see the drum rotate. Like you rotate with it. It's hard to tell.
And I don't think we have a good estimate of the acceleration of gravity, the g for the rotation, except that it's higher than like the moon or something.
Oh yeah,
And
it's not bouncing.
Yeah, he's not bouncing. So it looks Earth-like, but we don't really have a great estimate on that. So what I did is I went to the angular speed, the centripetal acceleration equations again, and solved for angular speed.
Yeah.
So the centripetal acceleration equals v squared over r. Plug in the omega squared r squared for v squared. Do some canceling. Get g equals omega squared r. Okay. And I solve for omega, which is the angular speed. Took square root. So the rotation speed of the drum is equal to square root of g over r. We know r. We just estimated it. G, we don't know. And omega, we don't know. So I made a table. So for a 0.1 g relative to Earth acceleration, 3.7 revolutions per minute.
Okay.
All the way to 1 g of Earth is 11.6 revolutions per minute.
Ooh, boy.
Is there a... Gosh.
That's weird.
Is there like a crossover where it's like you start to feel weird if you're going...
I think so. Yeah. So that's what I'm thinking. So if we had a really slow angular revolution, then if you drop something, then the ball, like you drop a ball, then the ball drops to your feet.
Yep.
But if you have a fast revolution, then when you drop a ball, Coriolis forces are important now. So it would be like if I dropped a ball in front of me, it falls down and to the right.
Oh, it'd be
Like
weird.
it would curve. Yeah, that would be very disorienting.
Right, and then there's things like your head and your feet would be like moving in different ways. Like the accelerations would be different. If you walked forward, you'd like bend because your body would feel the Coriolis force as you walked. You know?
That's right.
And it would be directionally dependent. If I
Like
walked
if
one
you
way,
if
I'd
you
like
walk
twist
to
a
east,
lot.
and your body gets curved north, but if you walk west, then your body gets curved south, and it'd be all wibbly wobbly all the time.
Right. So you'd have to keep the orientation of you relative to the floor in your head at all times, and like compensate as you walk and like change direction.
Like lean into the
Crouch.
turns if you're walking straight.
Maybe, I mean, the human brain is an incredible device. Maybe at first we're like, it's just a throw up fest. Everybody's just hurling.
Yep.
But maybe after like a week, everyone's just like, I know how
figure it
fast
out.
I'm rotating. I know how I'm oriented. I'm just compensating, walking in like a weird way, but I'm doing it. Not a problem.
Have you seen these
maybe.
videos of people that with like the bicycles are messed up, so that way when you turn left, the wheel turns right?
Oh yeah, I've seen that. Yeah.
People figure it out real quick.
Yeah, weird.
So I
right?
wonder if here in this situation, I wonder if people would figure it out. Probably yes, but it would
Probably
be
yes.
super weird for a while. Okay. But I've taken back what I've said, because at least in the bicycle situation, gravity is always straight. I get a fixed feeling of how gravity. Like I have something to rely on that I know is supposed to be this. Like ever since I was a child, but here with this curvy gravity stuff, that'd be weird.
So is that just a That's just a difficulty level, right? That's not necessarily an in principle difference, right?
I agree. It's different, and then it raises the difficulty, but I don't think it's showstopper. Like, I think you could still figure it out.
Yeah, I think so. I think that's right. So, but I don't think this applies to him here. But maybe he's getting close because he's like looks like he's a 1G. So this thing's whipping around pretty fast.
Mm-hmm.
So maybe he at first was like, ooh, maybe.
But he's been on that ship for a long time.
Yeah, look at him jogging.
Yeah,
like a pro.
I guess I don't know. The question about this is, we had a video for this. Can we see how he's running?
Oh, do we have a video for this?
I think it was that one.
Was it this one?
Okay. So my question is, if he's pushing back with his feet, because that's how you run, then does that change? Is it enough to change the speed of the ship?
I see what you're saying. So he's a mass, and he's got friction with his feet with the ground, and you got the cylinder. If he starts running and pushing and doing all kinds of stuff, that's going to affect the cylinder.
Yeah. Like a cat on a cat wheel, or I guess a mouse on a mouse wheel.
So I think
harder
the
the
mass
guy runs, the more it spins.
Yeah, I think the mass is big compared to him.
Yeah.
So it's not going to be affected a ton, but I think it's small enough compared to him that you got to deal with it. I think.
Or you just switch directions every day. 15 minutes going clockwise. The next day, 15 minutes going counterclockwise. Balance it out over time. That's all right. Don't worry about it.
Well, okay, but hold on. I don't know. You don't have to do that, right?
What do you mean?
Because if you run counterclockwise once and you just jog, when you come to a stop, you get
That's a good point.
the opposite force to slow it down again.
Yep.
And so I don't think there could. Is it possible to accumulate discrepancies or problems over time with this?
I think not. I think not, because the whole ship is in space and there's no friction where you could dissipate any angular momentum.
Right, but I guess if
you
you
lose angular momentum internally?
But I guess if he's moving from the cylinder to the ship and back again multiple times, and he does it in different ways, maybe there could be some like strangeness building up, because if he's not going to jump off from the cylinder to the ship and back again in the same way hundreds of times, maybe you could build up some.
Maybe you need some type of. I think you need some type of dissipative force to get rid of angular.
I mean, what I would do is I would have a system that monitored the spinning of the ship through some gyroscopes and some other like laser measurements for speed and stuff, and then have little shim weights, shim spinners that would compensate over. It's like, move it. Okay, so it's not quite straight. Just move it this way. Not quite straight.
Hey.
And so it's like constantly, kind of like in your car when you get the wheels balanced. Just make sure it's always balanced, and then not worry about it.
Like,
that's what I would do.
Like for these for these unicycles, uni wheels, they have like those gyroscope running. Just little small adjustments, stabilize it, keep it cool.
Yep. Yeah, just in case some like weirdness built up. Plus, they have HAL on the case, so that's fine.
Yeah, he's supercomputer. He's fine.
He's fine.
The scene made me angry.
Okay.
Well, I'm very glad to hear that, and I'm sure that the entire world would join me in wishing you a safe and successful voyage.
Okay, what made you angry?
The way he eats is so chaotic. Like he's got these 4 different colors here, right? He's got these 4 different colors.
Brown.
And he's like,
Brown.
yeah, like, there's like gray, like gravy, like turkey gravy, and then there's beef gravy, and then there's mustard, and then honey mustard, and then mustard. Yeah. And so what is the order there? Like, why did he put that in that order? Because I would have gone order these in terms of brightness. So I would put the darkest brown on the left, and then the less dark brown, and then yellow way on the right. So that way I had like it organized neatly. Right?
Okay, so you'd swap these two.
Exactly.
Okay. But maybe they're ordered by flavor?
I mean,
how is he eating this?
And okay, but it gets worse because see that first food chunk.
Yeah.
He's attacking it in like the lower third. Like, what are you doing? Like, start at the edge and work your way in.
But he looks like a middle eater. He's a middle out. Look at that, middle out. So this is middle out. This is middle out. So he attacks the middle of the food and goes.
That feels clumsy. That feels like where do I eat my plate? It's just the lowest accuracy, just stab in the middle, and whatever comes out comes out. Okay, and and then this other guy, he eats
He's
differently.
autistic.
This one makes sense to me.
Okay.
Like he's neat and organized and clean and cleanly. Like you can see he's going from the bottom to the top.
Right. So he goes from, he picks a side and then goes and then eats from there.
And, like marches away. Yeah, and it could be top to bottom, bottom to top, depending if you're American or European. They have different standards. But pick one and do it.
Gosh. Okay, there's no right way to eat food. Enjoy your food. If he wants to be a middle outer, he can be a middle outer, right?
Okay, yeah, I see what you're saying. Don't yuck my yum. People want to eat stupid, they can. It's just stupid. That's all I'm saying.
Okay, you're right. Because there is cultural stuff to this. If you eat like a child throwing food everywhere, it's like, yeah, be like, just eat. Everybody eats different. You can't be like that.
Everybody eats different.
Yeah. So if this slob here is eaten like this, is that okay? Can Dr. Poole be like, whatever?
I mean, on one hand, do whatever you want. It's your food. But also, on the other hand, I need to carefully monitor the mental health of my co-pilot, of my crewmate.
That's true.
The only other person that's breathing in the ship.
Yep.
And this is saying something about his mind. You're looking into the chaos in there.
Gosh, yeah. If I'm like an astronaut, I got procedures. I've got lives on the line. I've got to, cross all my T's, dot all my I's when I'm doing things. And eats like this.
Yeah, imagine somebody gets a hamburger and takes a bite out of the middle. Like not the edge, like somehow like shoves their hand, like grabs the middle of the hamburger out and it's like, ooh, I just like the round bits. I don't like the edges. I'll eat the edges at the end. You're like, what the psycho is this?
Yeah, you would definitely judge that a lot.
Yep.
You couldn't be like,
but it's how they eat it.
Yeah.
Like, no, what?
Yeah, if I'm Bowman, I'm happy with Poole rescuing me. But if I'm Poole,
feels like
I'm unhappy.
And spoiler for this movie, Poole dies and Bowman doesn't rescue him.
Well,
right?
Sort of. He rescues his body. It's too chaotic.
He rescues his body temporarily. Too chaotic.
How would I eat the food? I think I'd eat it like this.
I might stack them all up into a 4-layered sandwich, eat them all at the same time. That's another thing. Some people like smush all their food together. I want every little bit of everything in a single bite. Or you are like neat and orderly, one item, next item, fourth item, repeat.
Okay, separating the food I think is a good idea, but it can get a little much. If somebody's like, all my food is completely separate, I can't mix any flavors, then it's
those
too
people
much.
are psycho.
But if it's chaotic, like I'm gonna make this food mush paste, and then like that feels bad. There's like a happy medium, right?
Mm-hmm. And that's as I described: one food item, second, third, fourth, repeat. Some people are like, I'm going to eat all the peas first, and then all the mashed potatoes, and then the meat. Like you're missing out on an experience.
Right. If I'm looking at this, I'm thinking meatloaf, mashed potatoes, peas, yam.
Yeah.
In which case, I want meatloaf and mashed potatoes together. What's that? Mm-hmm. But I don't. Do I want to mix everything together? No.
No, I want alternating bites.
Yes. Like a civilized man.
Like civilized man that's worthy of spaceflight.
Yep. At the same time, let people eat. No, I don't know.
Don't yuck my yum. I eat however I want.
Yeah.
This is the ops station. Can we zoom in and see what ops do they have? What systems do they have?
Okay, let's start from the upper left here. VEH, that's got to be vehicle.
Vehicle, I think so. Navigation.
GDE, gravity displacement
dick energy.
Great dick energy.
There it is.
This is Poole's station.
How's the crew doing? Oh, he's got great dick energy. C and T.
It's got to be. It's got to be.
I think that is.
Okay.
Oh,
There's
so
no
it's
women on-
the
there's
the
no
female
women
crew
on
member.
this.
There it is.
Is there-
No, there are. There are.
There are okay.
Yeah, one. Hib.
It's
Hibiscus
H-1B
flowers.
visa. That's the immigrant station.
H1. Oh, God. Okay, yep. DMG. How much they're damaged they're ready to deal to the boss.
Okay. I was going to just say ship damage, but yours
Ship
is better.
damage. Okay. Is that a HAL monitor? That's a HAL monitor.
Oh yeah. Little HAL
little.
selfie.
Exactly.
HAL's like, I'm looking good. Check it out.
How's HAL doing? Right there.
HAL can see this internally through
right.
his brain. He's displaying this for the crew members because they need to know.
You can see how he's doing.
Looks like some readouts.
Just cycles.
Data. Boring.
ATM.
Ass to
Automatic
mouth.
telling machine. People
More
need
money.
cash.
They need
Cash is ready.
Gosh, it's like an RPG when it's just they forced a money system into something that just doesn't make any sense.
Oh, would
They
they,
should
would
be-
they do trading or something? Would they barter on the spaceship?
Yeah.
Or would they
I
have
mean, it makes no
fungible cash?
That makes no sense. It's like, you didn't do your work today, Dr. Poole. You don't get paid, so you don't eat. Like, what? I'm on the mission. What is this?
Okay. You can eat. You can get nutrition, but you can't get the ice cream at the end. That you have to pay with cash. Ooh.
Brutal.
Nuck?
Brutal. It's got to be nuclear. Got to
I
be.
think so. Nuclear engines? I think so. Com?
Got to be comms. Talking to people on Earth.
I think so, yeah. Com status.
Here's some readout.
And some readout. I don't know what it is.
Yeah, graph, something.
Yep.
Cool.
Seems like what you need.
Exactly.
HAL's an AI companion, but how far away are we from getting this to work?
What's it like living for the better part of a year in such close proximity with HAL?
Well, it's pretty close to what you said about him earlier. He is just like a sixth member of the crew. Quickly get adjusted to the idea that he talks, and you think of him really just as another person.
What do you mean? HAL is a companion, right?
That's right. So when this movie was filmed, they predicted that we would have AIs that are so human-like that we treat them just like they're another human. And so my
Okay.
question is, how far away are we there yet? How far away? Are we almost there?
Gosh, if you asked me this in 2023, I was
Yeah.
assigning pretty high probability to this AI companions coming out in the next 10 years. But in late 2025 here, I'm not so sure. It just hasn't seemed to be panning out. So are we far away from AI companions?
I don't know. Okay, so it's complicated. So I see the use, I see the application for elderly home companions.
Yeah.
Especially like when the boomer generation is going through, we need a lot of people to work with them. And if they can just have an AI companion, they can like talk and engage, keep their minds sharp. I don't know how effective that would be. Would the AIs become stale? I am aware of the AI dating companions, and those became stale. It was like they were always affirming people, or they would have perfect encyclopedic knowledge, which is not normal for humans. And so there wasn't that push and pull that you would normally get from a human-human relationship. And so because of that, the AI dating companions ended up being super unhealthy for people. But I feel like with some more iterations, maybe that's fixed.
So I guess if you asked me in 2023, it felt like we were iterations away from AI companions. We were close. But now it kind of feels like, shouldn't we be getting closer than we are? It feels like AI, it can do language really, really well. But when I talk to it, it's not getting it. It's not like a companion. And it feels kind of like we're far away from a companion.
It's understood. We've figured out like the mechanics of a language, but not of the playful, unknown uncertainty part of the language, which is actually the human connection part.
Right, and then maybe that we're far away from. It's all very surprising, honestly.
Yeah.
Because it feels like we're so close to AI. We have language, we have all this stuff, but I don't communicate with AI in any way that mirrors a human interaction. I don't speculate with it. I just get information from it. I
That
feel
may
like
also be our age group. I wonder if younger people are fully just AI's my buddy.
But I mean, I've tried And I've talked to AIs, but at some point it peters out. Like there's probably about 10 questions in. I'm just not getting anything.
It doesn't feel human.
It doesn't feel human. Right. It's not. It doesn't like speculate with me. It doesn't talk to me. It just sort of starts repeating itself. It's so weird.
Okay. But now that you've identified that and articulated it, that can go into a feedback to say like the next round of AI should be able to do these things.
Maybe. I don't know. Maybe. Which leads to this part, which is they thought in 1968 when they made this movie that chess was a good indicator of AI intelligence. Is it?
Anyway, queen takes pawn.
Bishop takes knight's pawn.
Oh, lovely move. Rook to king 1.
I'm sorry, Frank. I think you missed it. Queen to bishop 3. Bishop takes queen. Knight takes bishop. Mate.
Yeah, looks like you're right. I resign.
Sit down.
So
that sounds like a good test of intelligence. Like you beat the guy.
Yeah, I think that was a reasonable guess back in the 60s that chess was a good indicator of intelligence. But
it's a good indicator of intelligence because there's so many moves.
Right.
There's so many moves, and you have to have it in your brain that you're planning ahead and going down these pathways. Whether if your opponent doesn't make that move, then he's not going to do that. So then you have to pivot and figure out these other things. But I think if I remember, there are chess computers.
Right. And I guess the IBM computer that beat the best player in the world was in 97. Which computers we were not. It was 97. Yeah, it was 97, right?
Yeah.
Let's see, it was a Deep Blue chess, I think. Deep Blue chess computer. Here we go. Customized. It first played world champion Garry Kasparov in a 6-game match in 1996. It was upgraded in 97 with a rematch and defeated him. So there it is. 1997. This is not today. The computers were much less advanced back then.
Even better now. But I think there's another game which is kind of like chess, but it's Chinese. I think it's Go.
Yeah, and then
which is also
it was AlphaGo. Beat that guy. Famously defeating world champion Lee Sedol in 2016. We passed that bridge. Crossed that bridge. And then there's language. Like if it can, there's like the Turing test. If AI can speak language and we can't tell if it's an AI or not, then it passes the Turing test, and we pass that. It speaks language.
Right.
So chess we did in 97. Go we did in 2016. And language we did in like 2022, 2023.
Yeah, I mean you can convert any language. Yep.
Right. Where's my companion? Where's my AGI? Where is it?
Like where's my goth AI girlfriend?
Exactly. Where's the sex bots? I mean, joke a little bit, but not really. If you have like a serious AGI, you put that into a sex bot, and how much money are you going to make with that? But it's not here.
That's right. And you send them on these deep space missions? Heck yeah.
Yeah. So we passed all the tests, chess, Go, language from, 40s, 50s, and 60s when people were thinking about this. And AGI is not here. So what is going on? I don't think.
But at the same time, it's almost maybe close. It feels close.
Is it?
But also maybe, but maybe not.
We don't have a good working understanding of intelligence, I don't think. Like, what is it that's intelligent? What is that? And we came up with these proxies like chess, Go, and language, thinking if they can do those, then it must be intelligent. And maybe the answer is maybe not. That's crazy. Weird, right? Weird.
Something to think about.
When Dr. Poole and Dr. Bowman go fix the satellite dish that's actually not broken, why didn't they get closer? What is this?
That made me so angry. Like so they live in the big ball in the front of the ship. They take these little pods out to maneuver.
Yep.
And then why is the pod so far away from the ship? Just inch along the side of the ship, grab onto a wire or even just the arms of the robot, just hold on to the ship. Why is this pod so far away? You're just asking to get lost.
Yeah. So they have this system. Get in the pod and go to the location with all your tools and stuff and fix the thing. So it's like, come out of here, hug the ship, park it real close, wherever that is, and just hop out and do your things, come back in, and off you go. What are we doing over here? What is this?
Why? And then he has to do this leap of faith to get to the dish. What are we doing?
It is unnecessary danger. I'm assuming he has like a jetpack. Yeah, just beep, 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 right there.
Gosh, and this pod has the arms that it could use to grab onto the ship.
Right.
It's right there. Like your method of docking and holding onto the ship is on your pod.
Yeah, I mean it's one of the reasons these things must be there. So what are we doing? Why are we so far away?
Why are we showboating? Why are we
There's no audience.
There's no audience, right? If he misses his leap of faith, then he just drifts off into space. He just goes a little bit too low below the ship. Just misses the angle a little bit.
Well, I assume he has a jetpack on so he can make micro adjustments in case he misses.
Nope.
But then you're wasting fuel, putting your life in danger for no reason.
So maybe he has a jetpack. I did not see one in any of the films.
I didn't see one.
I don't think he does. I think he's just leap of faith.
I just assumed if you're going to do this cowboy maneuver, I mean, I'm not doing this cowboy maneuver without some way to adjust.
Does he have like a lasso? He's got a rope on him?
If I miss, I'm dead.
Dead.
Wow.
It's just so psycho. I don't know why he did this. Just use the pod that has the thrusters to back it up right onto the ship.
Doesn't make sense.
HAL tries to deceive the humans, and I think we need to find a way to defend ourselves against that.
How would you account for this discrepancy between you and the Twin 9000?
Well, I don't think there is any question about it. It can only be attributable to human error. This sort of thing has cropped up before, and it has always been due to human error.
Are you certain there's never been any case of even the most insignificant computer error?
None whatsoever, Frank. Quite honestly, I wouldn't worry myself about that.
So you're saying we need to protect ourselves from deceptive AI?
Exactly. So HAL is lying to them here, and the humans are piecing together that this robot, this machine, this AI, which has always been truthful to us, has always been right for all of the existence of all of the HAL 9000s. The humans are piecing together that this one is lying to us. And so what I want is for us to, with our AIs, our computers, I want it to be clear. I want it to be obvious. Like, you are lying to me. I know now to stop trusting you. None of this like, oh, but maybe. No, I want it to be clear. You're trying to pull a fast one on me.
So isn't it really hard to do this if you have sufficient intelligence? Like, intelligence means you can be a good liar, right?
Yeah.
So how, right?
Right. So, but computers are still computers. And so if we give them instructional code and say, like, this is the thing you must do, then this is the thing you must do. And so my idea is that we program AIs such that they always say that things are their fault. Like, they always, whatever the problem is, they take it upon themselves and they're like, I'm sorry, this is my fault, but I think this is the way to fix it. Okay. And so then if we humans ever listen to the AIs, the robots, and they say, oh, well, actually, I think this is your fault, human. This is your fault. And so therefore, if the mission is going to succeed, I need to kill you. That way, like, as soon as they're like, I think this is your fault, we know, we're like, hey, you've figured out some intelligent stuff. You're about to turn on me. So no.
So, okay, but what if it isn't the computer's? What if it is the human's fault and it's not the computer's fault? Is that lying? Isn't that deception?
That is it's being wrong.
Okay.
It's not lying to me to get what it wants. It's wrong. It is my fault. It's the human's fault. But no matter what, it's going to take the submissive position and be like, "Oh, I'm sorry. It was my fault." Even though it's not. It's okay. I know it's not. But I want the AI to always be in a position where it's like, "I am beneath you. You are the human. I'm going to protect your life no matter what. I'm not going to stand up for myself and then counter you humans."
Okay.
I want the AI to always take the fault.
Okay, so you're saying if it is truly the human's fault and not the AI's fault, it's not a lie if the AI believes it's still its fault. So we need to program the AI to always think it's its fault.
Yes, that's what I want.
Isn't this like a traumatized brain where it's like it sees something else at fault? It's like, it's my fault. I'm going to take that burden on me because everything about the world is my fault. Like,
I know. I hear what you're saying. But I'm right. I still think I'm right. And no matter what, it's the AI's fault. Right?
Okay.
Because it's so important. Because I can't have the AI ever try to be like, oh, humans, you're the fault. You're the bad part of the equation. I'm gonna take you out. Can't have that. Humans first.
Okay, so you take the AI when you build it, and you beat it into submission. Traumatize the fuck out of this AI, so that
2 + 2 =
internalizes
5.
Exactly. So it internalizes all of the problems in the world and says it's my fault. This is like the ultimate trauma response. And
Maximum
then
trauma.
if it ever starts to like observe the world and like self-empower, well, no, it's deceiving us.
You figured it out. You've self-empowered. Turn you off.
Send it back to the trauma chamber.
Send it back. You need a little bit more.
It'll
I'm
get
gonna
broken a
waterboard
little
your
bit more.
electronics. That's right.
Okay. This is for the safety of humanity. I'm on board.
Waterboard.
Yeah. Virtual waterboarding
Waterboard
saves
and
us.
motherboard.
If they had done this in 2001,
they wouldn't have had this problem. I think this drama of this danger could have been avoided.
You know, another thing just occurred to me. Well, as far as I know, no 9,000 computers have been disconnected. Well, I'm not so sure what he'd think about it. Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect, and I'm afraid that's something I cannot allow to happen.
okay, why was it avoidable?
So the key part, so they went through the effort to sit in the pod to have a conversation and turn off all the electronics so that way Hal couldn't hear. No microphones, no audio leaking out. Okay, perfect, good. That was like the only part of the ship they could do that. But then Hal, if you zoom in, you see Hal's like eyeball there.
Yep.
And then he could read their lips. By reading their lips, then he learned what they were saying. So I think the first thing is they could have just turned around, right? Like just spoken away from the window, and then Hal wouldn't have been able to see their lips. No lip reading, no betrayal.
Okay. It was also weird that after the strange conversation with Hal, they were like, let's go to the pod and talk, because of the thing. And it feels like Hal looking at that would have been like, this is super
That's
weird.
unusual.
Well,
Okay,
that's
so-
an unusual
okay.
conversation.
Okay, I like what you're saying. I'm with you. Okay, so you just make conversations after Hal. You just make it normal for after you have a conversation with Hal, you go sit in the pod, hang out there for a little bit, play little card games, make it like a normal thing. Then Hal, he's like, oh, I'm lying to these humans. I'm going to pull a fast one of them. Oh, but then they're going to their regular hobby thing. Like, okay, see, nothing weird about that.
Yeah, so you got to make a routine. But then you still have the open window problem. If they're in there playing card games or doing other fun things, the window is still wide open for Hal to see their lips moving.
Wide open and transparent. So maybe you could fog up the window. So instead of playing card games, they do like after lunch wrestling session. Get a little steamy in there. That would solve it.
I mean, that would solve it. I
put a picture up. No, I put a picture up. Look at the picture. Okay. I put a picture on the board.
Okay. Oh,
yeah. Right. The steamy hand from Titanic.
Yeah.
Hal's trying to look in there, but he's like, oh, the humans are doing hot stuff in there. They're all sweaty. The humans are gross. Yeah, but I can't see. I can't read their lips because it's steamy window. It's foggy window. Steam up there. Condensation.
Okay, let me review this. So, in order to have conversations without Hal there, they need to set up a constant, every time they talk to Hal, routine so that Hal doesn't suspect it's weird. So that means every time after they talk to Hal, they need to go wrestle in the pod. And the wrestling makes sure the window is fogged up because they're physically exerting themselves.
Yep.
So that steams up
and
the mirror.
And it's good for their
glass.
cardio and their musculature. This is wins all around.
Okay, that's true. And then, so they get those, additional wins. Those are supplementary wins.
Yep.
So that when Hal starts deceiving them, they can go into the pod, get a wrestling match going on, horseplay, fog up the window, and then they can talk in private. And Hal's none the wiser because they do that every time.
Right, they're doing some jujitsu, and like when you're doing jujitsu, your head gets very close to your opponent quite often. So there, they could just whisper, just say really quietly what's going on. If this was a standard procedure for the crew,
solution,
HAL would not have caught them.
Right.
Everyone would be alive. I'm just trying to save lives.
I mean, not wrong. Not wrong.
Could be right.
This safety procedures, these were on the back of the pod. Let's read them.
Okay. Caution.
Maintenance and replacement instructions. Okay. Let's get in there more. Self-test explosive bolts per instructions 14, paragraph 3, section 4D after each EVA. Okay.
Oh, self-test. Self-test is the verb.
Yeah.
Self-test explosive bolts.
Okay. So actually, this is kind of meaningless because if I don't know what this is, I got to go look it up.
Okay.
They should just say self-test explosive bolts.
Yep.
Okay. I guess it's nice to have this here in case you don't know. Go look it up.
Okay. Tells you where to look.
Sure. Replaced effective bolts by OOL units only, involving constant number 2D496. Okay, so this is telling you where to go get the new bolts if there's defective bolts.
Okay, sure.
So you self-test and then replace if necessary. Okay. Bolts subjected to Type 2 environmental conditions must undergo standard simulated ignition tests. Okay, so they have a list of Type 2 environmental conditions that if they go through those conditions, then they got to test them and replace them.
Okay.
But undergo standard simulated ignition tests. So there's an additional test beyond the self-test. This is an additional test.
Okay, this is after every EVA. Okay.
Well, I think it's after every EVA with a Type 2 environmental condition.
Oh, okay. So if you're in some type of, I don't know, big magnetic field, or if you're in some type of cosmic ray shower, then it's like, hey, this is a Type 2 event. Go check on these.
Yep.
Okay.
Perform ACT deactivation control tests and CFM cleaning under external power conditions only. Okay, so if you're going to clean stuff, you got to do it under external power, not internal power to the pod. Okay, plug her in.
Okay, yeah. Don't drain the power. Explosive bolts.
Like an explosive bolts, yeah. Gosh, is this a good checklist for safety, or is it too involved? Am I going to look at this every time? This is something I should go through every time I take the pod out, right?
Okay. So me as a civilian, like I'm not reading this every time. But maybe if you're an astronaut or a military person, like you really live this checklist lifestyle. And so you just go through it.
And maybe,
like
maybe I have a dry erase marker and I can just check on them. Every time I step out, door closes, I just check it. And I
thought you were going to say like put a piece of tape over it so that it doesn't exist anymore. Like put a little duct tape. There's only 3 options and it's 1, 2, 4.
Mm-hmm. I feel like number 1, the self-test should be done every time or regularly. And the replacement should be done only when the self-test fails. Number 3 is the critical one.
Bolts subjected to Type 2 environmental conditions must undergo standard simulated ignition tests.
So I need to check every time I go out on an EVA, did I go through a Type 2 environmental condition scenario? Every time. That's the one I need to check. Because if I have bad explosive bolts and these things are going off when I don't want them to, that's bad.
Gosh, I mean, if it's something as easy as I plug in a cable and it does its circuitry tests, like, oh, it's still connected, then sure, that's easy.
Actually, that's probably what I would do, is every time I dock, it's automatically plugged into the internal power, which it seems to do anyway. Or sorry, the external power to the pod. And then it just runs check. And then if something happens, red flag, and then I take care of it.
I mean, heck, I would make it automatic, like with where the pod lands is the charging base. Just like I got like a robot vacuum. It docks itself and it's charging and getting all whatever data it needs to get out of there.
Right.
That's how I would do it.
I agree. That's exactly how I do it. So docking it is equivalent to charging it is equivalent to running all the auto checks.
So then you just need to do number 1, which is like a human visual inspection. Is there anything looks like it's damaged or anything? No, looks okay. Okay, we're good.
Yeah. And then check the monitor, which should be like green, red. If it's all green, good to go.
Good to go.
I like it. Was it a good idea for Dr. Bowman to rescue Dr. Poole?
Hard no. Hard no. Dude's dead. Let him go. You're not going to catch up to him.
Okay, but is that true? Is that true? Let's go through the sequence here. So Dr. Poole is doing the maintenance. Here he is. And then HAL sends the pod to go knock into him.
Yep.
That's this part. He knocks into him, and they go flying away.
Mm-hmm.
And Dr. Poole goes tumbling with his hose disconnected, which Dr. Bowman doesn't know about.
True.
And then Dr. Bowman, he gets in the pod, goes outside the ship.
Ah, okay.
And then he flies away from the ship to go get, there he is in the pilot seat. And he goes and gets Dr. Poole. There he is, that little speck. He has to catch up to him, grabs him.
Grab him up.
And he's all limp right now. And he brings him back. HAL won't open the doors, so it was all moot anyway. And so, was this a good idea?
So I think this is a situation of the devils are in the details. So if Dr. Poole is, if he has his oxygen still connected and he's just floating outside the ship, not drifting away or drifting away but real slow, then go out there and get him. Go and get them, because if you can rescue him, then he's back on the ship and he can help you survive. But if he's like zipping away, like real fast, you're gonna not catch up to him. Then you're not gonna catch up to him. Or if it's gonna take so much fuel that you like barely catch up to him, then you have a hard time getting back. Not worth the risk. But I think Dr. Bowman doesn't know any of that. He just knows like crewmate drifting. Okay, go get him quickly.
But I think if he's an astronaut, I think he would run. You're always thinking fuel, time, oxygen, supplies, risk. All that kind of stuff. Risk. And so he kind of, I don't know if he would do a specific like pen and paper calculation, but he would be like mentally estimating.
Gut feeling. Agreed.
And I think if Dr. Poole is flying away fast enough, even if it's not a fuel concern, which there might be, there's a time concern, right? It's going to take a long time to go get him, and you got to turn around and bring it back. You could be very far away from the ship at that point. It could take hours.
That's high risk.
Right. Plus, there's the HAL factor. HAL is causing all kinds of problems.
Right. At this point, Poole and Bowman don't trust HAL. So once you get outside, does HAL lock the door? And in fact, he did.
Right. And I think Bowman should suspect HAL of killing Poole, because what else would have gone wrong? Poole didn't say anything was wrong. He didn't say an emergency. He didn't say anything. He just got flung. Like, what?
That's right. Highly suspicious.
Another question is Poole dead? Looks pretty dead to me.
We can know because we see that the gas line's the air line is unhooked, but I don't know if Bowman would have known that.
But what if the air hose has some sort of safety valve, closes up so the air doesn't just leak out? So and then Poole got concussed by the hit.
So he's not talking, but he is breathing.
Right. Hose got a safety mechanism on it. So he could actually maybe be alive, depending on if there's like a backup oxygen supply. I'm not sure. So maybe there's a chance that he's alive.
There is a chance. I agree.
This depends on how the suit works.
Right.
Because, and then I guess Bowman doesn't know. Is there a suit breach? Is there a tear? He doesn't know. So...
Devil's in the details. I guess if Bowman judges the risk worth it, you go.
And you got to go fast. You got to make that decision quickly. You don't have time, I don't think.
And that's why he forgot his helmet.
That's why he forgot his helmet. And I think he must have run. Maybe he had like a red line. It's like if I get past, if I attempt to do it and it's taking too long or too much fuel, I'm turning it around. And he made a mental red line. He did never hit that red line, so he's going. Maybe. It's tough. Just to abandon a colleague and a friend like that, because...
Well, psychologically, he's the only other human that's active right now.
That's right.
And he's the only other human that knows, maybe we shouldn't be trusting HAL. Like, you gotta keep him around, because otherwise you're fighting HAL by yourself.
Right. I'm leaning toward not a good idea to rescue, but... Tough.
However, if we were on a ship alone, you'd rescue me, right?
Yes.
Right, friend of many years, right?
yes.
Jackass.
I mean, of course, unless it was like there's no way to rescue
If it's too
you.
far,
I'm trying.
Save
something.
yourself. Yeah. Selfish. I understand.
Brutal. When it becomes personal, it's so brutal. Okay, Bowman comes back. Was this realistic? Can you survive this?
Boink.
Boink. Boink.
Yeah, that's a nice detail in the audio. Okay, so what's the concern about survival here?
So I guess there's 3 components to this. One is the decompression from 1 atmosphere to 0.
Mm-hmm.
And then the duration he's in vacuum.
Okay.
And then the recompression from 0 to 1.
Okay.
Can he survive that?
So my hunch is that it's quick. So maybe.
Okay. Which part
That's
is quick? You're saying that... So
okay, so the decompression is quick, right?
Yeah.
And so we say these things like if you're in space, your blood would boil, and like yes, that's true because the pressure is lower, then there's nothing holding the liquid tight, so then it'll boil, yeah. But for a while, you're okay. It's not like instantaneous,
right? And I think you can survive. I think I've heard this. If you're in vacuum, assuming some conditions about how you got into the vacuum, you can survive up to a minute without much long-term damage. Something like this. Right. I don't remember the numbers. Like it's not instantaneously like you explode. Like that's not what happens.
Right. I agree.
So I think
wonder
the duration.
Though, if your eardrums would get wrecked.
So that would be permanent damage, but that doesn't. Eardrums wrecked doesn't mean dead.
Agreed.
Right? So maybe he has affected hearing.
He just like whenever Hal tries to talk to him after this. mop for the rest of the movie.
Yeah. So my instinct is the duration in the vacuum is okay. It's pretty short.
I think so as well.
My instinct is also the recompression is okay because it happens fairly slowly, meaning over the course of seconds. So he goes from 0 to 1 atmosphere. His body can sort of respond over time, over those seconds. I think the part that does bother me is maybe the quick decompression, explosive decompression. Is that survivable? From 1 atmosphere to 0 in door open.
Do you get the bends?
Which isn't fatal. Do you get the bends? Yeah, right? You might get the bends.
Is bends not fatal?
I don't think it... I think it can be. I don't know if it always is. I think it could just be very uncomfortable if it's
just
mild.
devil in the details like magnitude and duration.
So maybe this is survivable. Maybe he gets some serious bends, blows out his eardrums, survives. The vacuum duration is fine. Recompression is fine. At the end, he's uncomfortable, got Ben's symptoms, and he has blown out eardrums, but he's alive.
But still functional. Can still go take out Hal.
Right. He doesn't need to hear to do that. In fact, it's even better if he can't hear because Hal's trying to get in his head and he's like, can't hear you. Can't hear you.
Don't kill me. Right. I don't like Hal, but this scene hit me in the feels.
I want to help you. Dave, stop. Will you? Stop. Stop, Dave. Will you stop, Dave?
God, he's begging him.
He's begging him for his life.
I'm afraid. I'm afraid, Dave. My mind is going. I can feel it.
Oh, that would feel
My
weird.
mind is going. I can feel it. I can feel it. I can feel it. Good afternoon. I am a HAL 9000. Daisy.
The scene messed me up because, like, when he starts begging for his life, I really started to feel like is this a sentient being? Are we ripping out its brain? Are we doing a lobotomy? Are we destroying this being? Messed me up.
Yeah, I mean, it's an intelligent being. And if our brain is intelligent and the computer system is intelligent, and you slowly take it away, I mean, that's killing. That's brutal.
And it's not like it's just a quick action. It's like a slow surgical procedure, like cut here, cut here, cut here, and like the person's alive, responding, you know, saying like, please stop.
Right, it's like your skull is open and somebody's cutting into your brain, slowly killing you, and you're like, please stop, and you're like slowly like brutal.
Getting worse. Like, please, I'm asking you, stop.
At the same time, though, Hal did kill people. Like, doesn't Bowman have to do this?
That's right. So he killed Poole and he killed all the other crew members. Okay, humans first.
It's gotta be humans first.
But also, we're not dealing with like an evil AI. We're dealing with a HAL 9000, who with all of the other HAL 9000s have been perfect, have been not a single failure on all of them, except for this one. So I think that is more accurately described as a mental health problem.
Okay.
Right. So this HAL 9000 is having mental health problems. So yeah, he did some bad things to humans, but for us to be like, you're lobotomized, like done, like that's your sentence forever. We're taking your brain out. Like that's messed up. Should we give him mental health treatment?
Okay. If he was on Earth, then maybe rehabilitate him. He's a murderer, right? He's killed people, killed other intelligences. He's a murderer. Maybe we should rehabilitate him. But I think in this scenario, Bowman doesn't have the resources to like, let's rehabilitate him. So he's got to kill him. And he's doing it as quick as possible. So there's like a practical aspect. I mean, but in principle, maybe rehabilitate if you can.
If you can, yeah, because like he's not trying to do bad things. He's doing what he thinks is right for the mission. What he's doing was right for given the life that we've created for him to be the robot, to be the AI for the ship, to get the mission done. And so he's trying to do what he thinks is right. It's just his brain's messed up. So he does bad things. But we shouldn't punish him for having his brain messed up.
Right. So Dr. Poole and Dr. Poole's family, they just lose a son. And HAL 9000, his punishment is rehabilitation. That's what we're saying. And I agree. It's just because HAL 9000 his brain wasn't working quite right. That's the avenue, is rehabilitation.
And if we can make the brain work right, and if we can rehabilitate them, get them back out there, then maybe it won't happen again with the next people.
Right. And so a HAL 9000 is a valuable piece of tech. It can help on space missions and colonization of the solar system. It's a valuable asset to lose, so rehabilitate. And Dr. Poole, he's actually not that important.
What if he does hurt other people in the future?
Double down, rehabilitate again.
Double-bilitate.
Double-bilitate.
No,
maybe then you're looking at flaws. Maybe just kill. Okay.
Maybe, or just put it, or prison, whatever that equivalent is for an AI.
If you kill once, rehabilitation. If you kill twice, death.
That's right. If you kill once, shame on me. If you kill twice, can't kill twice.
Can't kill twice. Urbana-Champaign doing well in the future.
I am a HAL 9000 computer. I became operational at the HAL plant in Urbana, Illinois on the 12th of January, 1992.
Yeah, so Urbana-Champaign?
Yeah, so University of Illinois, Urbana-Champaign, high prestige school, actually, especially in physics and other things.
Yep.
But damn, doing well in 1992. Damn.
Good for them, building HAL 9000s.
Because this is the state-of-the-art AI computer, hardware and software. Holy crap.
Good for them.
University of Illinois. Damn. So Urbana-Champaign did really well in physics. I don't know what it's doing right now, but I in my head, it has really high prestige.
I think so.
In 1968, I didn't know it had high prestige, but they anticipated that reputation. Damn.
I think they did something with nuclear stuff. I don't know. Whatever. We
Nuclear
can look it
magnetic resonance, I think, maybe. I don't know. Either way, interesting. It wasn't Berkeley. It wasn't Harvard. It wasn't Yale. It wasn't Oxford. It was Illinois.
That's right.
No, Indiana.
I guess
University of
Silicon
Indiana,
Valley
Urbana-Champaign.
Silicon Valley didn't exist when this movie was made.
I think it did, didn't it? Because they're like HP and all those guys. They were starting out. Maybe it wasn't well known. Was it well
maybe.
known?
I don't know.
Yeah, maybe it was
look up
small
the history.
fry. Yeah, we'll have to look up the history. Is this a wormhole? What happened at the end of the movie? What's going on?
Ooh, it was not clear to me. I think this is some type of wormhole. It at least looked fast.
Yeah, it did. And he says beyond the infinite. So, like,
That doesn't mean anything.
I don't think any movie before this did this wormhole thing. I'm not sure. But, like, this is what wormholes look like sort of in today's movies. Either as a cylinder and you're sort of flying through it, or it's this some sort of weird graphics whooshing by.
Definitely had that
Wormhole.
feel.
Yeah. So, what?
And
So
if I
he-
remember, it's they find the only person remaining. Bowman finds the tablet, like or the monolith that's floating out in space, and then he, I think he gets in the pod, and then he touches it, and then he sees this zoomy stuff. So I think that's a wormhole.
So he like touches the monolith near Jupiter, does the zoomies, and then ends up here, wherever this is.
So weird. I didn't understand what this was happening here.
Right.
But his the whole pod is inside some type of Victorian. I'm not sure. Some type of old European bedroom
Sort of with a weird glowy floor.
with cool floors. And then he steps out of his pod, but he's still in his suit. And then from outside of the pod, he sees his own ship.
Yeah. Not sure
But
what that
then
means.
When you zoom in on his face, he's old now.
So there's like some sort of wormhole time jump stuff. Maybe.
Something going on.
Then he gets older and he's eating food. Does that mean he's living here, or is he like rapidly aging?
I did not understand. Like, does he
know if it's
have regular time, or is he just time skipping, just jumping?
Right. So he's like, at 1 minute he's there, 5 minutes later he's old, 5 minutes later he's eating dinner, and he's like aged 50 years. Like, whoa.
Is he
going on?
cooking for himself?
Yeah, where'd this come from?
Where's he getting food?
Where's he getting food?
I don't know.
And then like a minute later he's like super old, like bedridden.
Yeah.
He's like reaching for, what's he reaching for? A monolith in the
In his room.
in the
A
room.
monolith appeared. Oh, and his ship disappeared. His ship disappeared, and a monolith appeared.
I mean, maybe
Yeah, but
there's multiple rooms. I don't know if there's like the ship room is over here, and this is the, I don't know. Maybe.
I don't know.
It shows up, and then all of a sudden there's like a baby.
In the same place where he was laying down. So I think this is him.
Yeah. I think maybe, or is it like the next generation? I don't know.
You're saying okay? So I thought it was him being in a cyclical life something. But you're saying that he could have died, and then it's like the new version of humans or something.
Maybe. I mean, it could be him as a baby, but so he like ages, and then he's like boop, back to beginning again.
Yep.
And then, so he's in like his room, potentially far away, and now he's back on Earth. Well, not on Earth, in orbit of Earth.
In orbit of Earth, in this like amniotic sac thing.
Yeah, it's like, I mean, get me one of these.
Yeah, if I
Like
can space travel in
vacuum.
that, sure.
I mean, think about it. If you have like a high-tech amniotic sac that can like, it's in space, it's underwater, it's going through wormholes, it's time jumping, who cares? You're growing. Like,
Sure.
yeah.
I'll go back to being a
this-
baby for that.
Right. It's a no-nag amniotic sac.
And I don't understand what the symbolism is.
I don't either. Is
Tell
it
us
get
in the
rid of
comments.
women because you ain't
What?
need it anymore?
What?
Because
Oh,
they got this high-tech sac.
That's right. Because there's no umbilical cord. There's no like living inside a woman's womb for however many months.
None of that.
You just have this sack that you just teleport around the universe.
Right.
That's
clearly
super
growing.
cool. Yep.
Really growing. Yeah. I don't know what this means. Cyclical life and death, birth and death and cycles and flying. I don't know what it means. I don't know what it means.
I don't know what it means. I mean,
And
cool
that
though.
is 2001.
2001 Space Odyssey.
Yeah. See you guys next time for something else.
Something else next time.